Okay, let's go today what is the chain rule. The chain rule is one of the most powerful rule for differentiation. And here, to find the derivative of this one is just 100x to the third power. That's it. We move this one down and we subtract 1 to the exponent. That's it. That's the answer for this one. This is y. It's equal to this. This is y prime. Okay, but in this case, we need to use the chain rule because where it's supposed to be the variable, you have a function. It's like you have a function inside of a function. Then I'm going to give you some example that you understand it better. So how do you find the derivative of this? That would be 100x minus 3 raised to the third times 1. Because this one times the derivative of inside. Now the derivative of inside is 1 and doesn't make any difference. But let's see when the chain rule make a difference and it's really helpful. For example, to find the derivative of 1 over x, that would be like x to a negative 1. So the derivative of this would be negative x raised to negative 2 or negative 1 over x squared. Okay? Here we don't need the chain rule. We don't need the chain rule here. Another one, square root of x is just x to 1/2. So the derivative of this would be 1/2 of x raised to negative 1/2 or 1 over 2 square root of x. Okay, this one is the derivative of this. And here, the last one, x to the fourth, the derivative of this would be 4x to the third. Okay, that's it. We don't need the chain rule here because if you look at this, those are parent functions. 1 over x, square root of x, and x to the fourth. But when you have a function inside of x, like in this case, you have x plus 5. Where is x? You have x plus 5. Square root of x, so where is x? You have x squared plus 7x. And what is x to the 4? Where is x? You have 5x plus 7. It doesn't matter if it's 4 or 3. It's just where is x to any exponent, you have a function. So when you have a function, you have another function inside, we use the chain rule. In the first one, doesn't make any difference because the derivative of this one is 1. So the derivative y prime would be negative 1 x plus 5. Here that will be go up negative 1, so it will be here negative 2 times 1. So this case does not make any difference. But let's take a look at this one. So the derivative, that will be this one if I rewrite it as x squared plus 7x, everything raised to 1/2. So the derivative would be 1/2 of x squared plus 7x raised to negative 1/2 times the derivative of the inside. The derivative of the inside is 2x plus 7. Okay, so this one is the chain rule when we have the derivative of the outside times the derivative of the inside. Let's take a look at this one. Y prime would be 3 5x plus 7 squared, that is the derivative of outside, times 5 because the derivative of the inside is 5. Now the rule is something like this. If you're trying, if y is equal u to the n, what you do is y prime will be n u to n minus 1, that is the derivative of the outside, times the derivative of u. And u represent a function. U represent a function. So when you have as 3x to the fourth, for example, the derivative is 3x to the third. 3x is u times the derivative of u, that is 3. So the exponent, that is n, we move here to the coefficient and we subtract 1 to the exponent. So 4 move here, 4 minus 1 is 3, times the derivative of this. Okay? And the derivative of 3x is 3. So that is the chain rule. That is one of the most powerful rule in the derivative. Recommend this video to your friends if you feel it interesting, and thank you so much for visiting our channel and our website.